My name is Dylan. I'm from the US. I live in Phoenix, Arizona. I'd like to start, so the talk is React plus TypeScript, so I'll start with React. So I think if you had to answer in one slide what's good about React, I would probably go with this, that the reactive architecture is good, things are very modular, very separable, you have a number of loosely coupled libraries that can be made to work together in a fairly consistent manner. It leverages modern JavaScript, and of course it has probably the most vibrant JavaScript community ever in the history of JavaScript. As much as we've been fragmented over the past 15 or 20 years, we're quite unified more than ever around React and reactive architectures. If you had to sort of look at like what's wrong with React, and I'll throw Redux in there just because I can, there's a lot of challenges around building large-scale React applications. Or I imagine if everyone who raised their hand and said they use React got together and said, okay, what packages do I use? How is your application actually architected? What component library do you use? How do you, if you got together and did all of that, you'd probably have quite different answers unless you all work for the same company. And even if you do work for the same company, you might have quite a few differences. And I think there's just a number of challenges around building large-scale applications with React because there are so many decisions and there's not a lot of sort of forced architecture in place. And I think that's both its strength and its weakness. So I was reminded of this. I gave a talk at JSConf that the video should be out soon called React Already Did That. It was kind of a humorous look at the history of JavaScript. It wasn't really about React at all. But the slide I liked was from Yanni, who talked and reminded everyone how poorly React was received 5 years ago. And so these were some of the initial tweets, like basically, oh my God, JSX, just why? Stop ruining JS, people. I wonder if Lardison, who commented on that in May of 2013, still feels that way, or if he's embraced React. It'd be cool to find out. But you know, like, this is terrible. So do we really not learn anything from PHP days, right? So people really don't like change, and they don't like things that are new. And the reason I mention this is TypeScript came out that same year. And TypeScript had a similar polarizing reaction from people. People either immediately saw the promise of it, or they thought, this is terrible, you're ruining TypeScript, you're ruining JavaScript, you're turning it into Java, you're doing all of these things that you shouldn't be doing. I want this freedom of a dynamic language. But today, I think people have really turned the corner and said, oh, this TypeScript thing is kind of cool. So I think that's kind of the premise of this talk, is just those things. So, you know, just a reminder, like, why do we use TypeScript, or why is TypeScript potentially a good thing? Well, compared to every other sort of attempt at fixing JavaScript, TypeScript doesn't really try to fix it. It tries to work with what's there. It tries to provide a duck type system on top of JavaScript, rather than saying, I'm going to give you a new language that's going to generate horrible to read JavaScript. I'm going to take JavaScript and add some features to it. And most people think of types, but I think of interfaces. And interfaces are a form of a type. But the whole point to me on why we use TypeScript is for the interfaces. And that's because in JavaScript, we have no way to express intent of a block of code. And why does that matter? Well, it matters for interoperability. It matters when you say, I need to swap this dependency out with something else because it's too slow or it's no longer meeting my needs, but I don't want to break my entire application architecture, right? And so if I know the interface, I know what methods and properties are there and what's supported, I can replace it. Whereas if I don't, I sort of think I know, and then I run into every edge case that someone clever extended in a particular way. Now, people used to take Dojo workshops years ago for me, and they would ask me questions like, well, okay, how do I express my intent in my code? And I'm like, well, you write really good documentation. And that's not really an answer. But then the better question would be, where's my IntelliSense, or where's my autocomplete? And I have a very good memory. And I'm like, you're just supposed to remember every method and property and what they all do in your head. And that's like the perfect way to learn JavaScript. And people would look at me like I was insane. But that's kind of how my mind works. But having IntelliSense and autocompletion makes it so it's less about the specifics of a particular API, and it's more about understanding the concepts that you're trying to use and use them efficiently. So TypeScript, and how many of you use VS Code? So wow, almost everyone. So you've probably noticed in the past 6 months or so that even when you're working with plain JavaScript, it can tell you like when you're being inconsistent or when you're doing things that might not make sense. And that's because they've written a set of tools using the TypeScript language services to analyze your code and sort of look at what you're doing and try to help you write better code. And they're also able to do that for plain JavaScript, not just TypeScript, which is pretty cool. So I think that when you think about it, TypeScript is a duck typing system. So it's not saying, okay, I've got an instance of, say, a class or a hook or whatever, because class is a bad word in React now. But I don't care if that instance or that version of it was generated from this original factory for that, right? I just care, does it have these methods and properties of this shape that match my expected API? So duck typing means like, does it look like a duck? Does it quack like a duck? Then it's a duck, right? Not, is it genetically identical to a duck? Just for the purpose of the API footprint that matters, does it match all the methods and properties that a duck should have? So if you wanted to get started with React and TypeScript, a few months ago, it would have been a really painful answer. It would have been like, do all these things. And now it's just like, oh, well, cool. Now I can just use create React app -- TypeScript and I'm done. Oh, well, and of course, some NPM installs and whatnot, right? But that's pretty cool because I never thought that day would happen, right? Because React was so focused on Flow for so long, or so focused on some of their other languages that they use for various things. So it wasn't always that easy. Most reference applications don't use this yet because this is, a few weeks old that this has actually been supported officially, if that. I think it was announced at ReactConf, was that last week or the week before, so relatively recently. But that's a much simpler way to get started. I don't yet know if I agree with all the decisions that come out of the box using that approach, but again, it's like now it's a default feature that's built into the main way that you start off creating React apps. So I guess what I'm trying to say is, if I'd given this talk 6 months ago, this would have been like 10 slides explaining like how to configure all these different things, and now I can just say, well, just go use the Create React App version rather than like one of 50 different attempts at creating Create React App. Wow, I can't even say that quickly enough. CRA, we'll call it that. I couldn't think of there's so many different iterations and versions where people express their TypeScript opinion, but getting that built into the version of Create React App that everyone uses means that hopefully you'll get some sort of standardization consolidation around that. All right. So the other sort of thing so how many of you started using TypeScript more than 2 years ago? Okay, so almost no one. How about 1 year ago? Okay, within the past 6 months. Okay, so pretty steady progression, but almost no one more than 2 years ago. And I think that's pretty reasonable because I think that TypeScript in 2016 was really rough for React users. There were a lot of things that just felt wrong or hacky or unfinished or difficult to do. And I'm just going to quickly go through some of the items that were fixed as TypeScript has evolved to sort of show why I think that TypeScript is a good thing for React users. So the first one actually, oops, I pushed too fast, sorry. Go back. I have too many animations. Okay. So TypeScript 2.0 was released in September of 2016, so just a little over 2 years ago. And before this, the biggest complaint that I heard from React users was, okay, when I use Flow, I can incrementally add type definitions. But with TypeScript, I have to specify that everything is a string or a number or a Boolean or all of these things, even if it's obvious, even if it's a constant, or even if there's no way that this thing is anything other than the type that can be obviously inferred. And so with 2.0, the big announcement was huge improvements to control flow analysis. And control flow analysis is basically the process by inspecting the code and trying to understand what's going on about it without you having to explicitly specify everything about your code and what type it is. So at this point, that argument went away, right? The argument of, well, flow is better because I don't have to specify const x equals 10. I don't have to insert that it's a number, or I don't have to insert that it's an integer or a string or whatever I want it to be. I can infer it specifically by the fact that it's a constant and it's very clear what it is. So that kind of removed that one layer of unknowingness. And what was interesting is all old like React plus TypeScript, or just any TypeScript code in general that was at that time specifying all of those things, was now getting a bunch of error messages saying, hey, idiot, I know it's a string. I know it's a number. Whereas before, like 2 versions before, it was like, hey, tell me if that's a number or a string. So it was a nice flip in making it easier and more ergonomic to work with. 2.1 came out 2 months later. So TypeScript generally releases every 2 months, except when it's like it falls around December, or it falls around like Anders needing to take a 1-month holiday or something. I don't know. But once in a while, it's 3 months. But they release with a pretty regular cadence, which is really good because it's predictable. And what they added was this sort of foundation for metaprogramming in JavaScript. And so they have this key of query, sort of indexed accessors. I assume you understand the syntax since most of you work with TypeScript, and sort of mapped objects. And those made it much better to model libraries that were more functional in nature, such as React or Dojo or Ember or Lodash and so on. And then they also added a few different types, but the one that was important was partial. And without partial, it was really difficult to sort of have a state that was partially specified and then got updated with more details later. So it made it much easier to sort of say, this is the type, I only need a subset of that type for this thing to be valid. And then over time, more information can be passed in that's part of this bigger interface. So partial is really just a subset of a full interface and saying it's valid as long as it conforms to this full interface or some subset of it. So then 2.2 came out a couple months later, and it didn't really do a lot in terms of like, hey, I made React better, but it made React Native work the way it should. And the main distinction there was take my TypeScript code and convert it to JavaScript, but leave my JSX uncompiled or untransformed because I want to handle that in like my normal sort of React Native workflow. So what you start to see is like in the early days of React with TypeScript, it was like, okay, we got JSX support, we're done. And that wasn't really enough, right? So it's kind of looking at how to decouple the JSX from React, because JSX isn't just a React thing, right? It's a language syntax that could be used and is used by Preact and Dojo and other libraries as well. So then 2.3 came out, and it had default type arguments, which makes it much easier to sort of manage the case where I've got some properties and then maybe I've got some state that this thing cares about, or maybe I'm just using that state to pass it further down my tree. So what it did is to sort of let you say, you know, I've got a component that's a class, and I've got a couple of generic parameters. One of them is my properties. The second one's my state. That state has a default of, say, just a generic object that then can get added to over time. And so what that did is it made it much easier to express how a component's type was defined. Before this release, before this update, you might have like 15 different definitions trying to describe how this one class was defined. And then this squashed it down to one. So one of the nice things about TypeScript I find is that whenever they find scenarios where it's like, wow, the user has to write this really long list of things to try to describe how this particular API should work, they go in and they look at how they can simplify that and parameterize that so you can write it more generically or more abstractly, so that you're not writing what feels like tedious old style Java class definitions up top, which to me pretty much scares everyone away from the language. That's actually part of a bigger class of problems called variadic kinds, which is sort of a collection of problems, which is how do I define a way to describe very dynamic features, very functional features. So like higher order functions that return APIs that themselves generate higher order functions and so on and so forth. And the challenge with that is not that it's impossible to do that with TypeScript or that they couldn't add all those use cases in now. The challenge is how do I make it fast enough to make it so that the IDE can autocomplete without it feeling like Eclipse, which no one ever wants to use because it's like terribly slow, right? I mean, maybe Eclipse is fast now, but the last time I used it, it was like I could see it thinking while I was typing. And they want you to have your IDE, whatever you're using with TypeScript, be able to compete up with how fast you can type and think. So the idea is they will not introduce any features into the language that cannot be made super fast, which I think is a really good thing because it's a nice, strong relationship, not a strict correlation, but a really strong relationship to say we're going to create a type system that works with what JavaScript is, but that is so fast that it won't get in your way. So I think that's a really good design goal. So then things evolved and started to improve some more. And 2.6 through 2.8, basically late last year to early this year, had 3 releases that kind of improved the way things work with JSX. So one was before 2.6, I think you had to have a full JSX definition. You couldn't have like a fragment. So it was really difficult to describe, oh, I'm going to pull in this JSX fragment conditionally if I do this versus that. And then a lot of the sort of completion list includes for like this and brackets and curlies for JSX weren't really well supported. The pragma comments make it so that you can specify a different JSX parser or different JSX definition per file. So the idea being like, hey, I want to combine some code from React and Preact or React and Dojo, but they might treat JSX a little bit differently. So I want to be able to parse them differently and specify that. So yeah, that's kind of what happened there. Then 2.9 came along and it fixed tag template strings a bit better, allowing you to type your arguments for templates. So before this release, I would have made the argument that JSX was not, and template strings in general, were not a great way to work with TypeScript because you really couldn't express everything you could from like a pure sort of functional approach. So, you've got like create React subclass, I don't remember if that's exactly what it's called, but basically Hyperscript, sort of the alternative JSX, which is more of a functional notation, has always been easier to type because instead of having a template, you have function calls that have parameters, so they're easier to reason about. But this sort of leveled that. And this is commonly used in sort of style components or styled components and stuff like that. So there are lengthy examples showing this in the various TypeScript release posts, so I probably don't need to repeat those here. But basically, one by one, they've just been looking for things that people complain about and fixing them, which is really nice. And then the past few months, a big addition was supporting default props for JSX, and then having it easier to describe properties on function declarations, so basically having your default props working there. And so again, it was like just one of those things where you'd have to write some very verbose code to try to express the type definitions for this, and now it's considerably easier. Now 3.2 is coming out. It's due this month, but because of the US Thanksgiving holiday, I don't know when they'll release it, if they'll release it before Thanksgiving or after Thanksgiving. My guess would be afterwards because Thanksgiving's a bit early this year. But anyway, the variadic kinds thing, they made a big breakthrough on strict bind, call, and apply methods on functions. I cannot do this justice in 30 minutes, let alone 2 hours, because it's a very complex topic. But I would go and read about it because it's another big change that fixes like a whole class of things where I can't easily provide these definitions and so forth. So it's one of those challenges is when people are like, well, what are the benefits of TypeScript, right? And I think, well, okay, my team writes more consistent code, I have interfaces, I find errors earlier, and so forth, right? But like, what's a specific React use case where when I don't have TypeScript, I'm kind of annoyed? And the best one I can come up with is sort of prop types. And so having to define and use custom prop types in normal JavaScript versus doing it with a TypeScript interface, to me, feels really tedious, and a TypeScript interface feels very precise and consistent. I guess the other thing that was interesting is when Juho mentioned that he's been using TypeScript for 3 months and he doesn't like writing JavaScript anymore. And it's really interesting because, TypeScript really is just a small superset of JavaScript. And what it is it's really a set of linting tools and documentation tools and code accuracy tools, some of which are expressed in the form of language features, right? So yeah, you've got this generic notation and you've got these interfaces and you've got these type definitions and you've got support for some new features, but most of it's just ES6 or ES 2017 or 18 or whatever. But what's really neat is that some of the features you just get by using TypeScript, and some of them even work on JavaScript as well. Some of the tooling around code consistency and accuracy and describing how APIs work and so forth is provided by the tooling rather than something you have to do. So it's kind of part language addition, part transpiler, part static analysis tool, and part code linter. So TypeScript is really kind of all four of those things sort of working together to create better code. So I have a GitHub URL to an example application. It's not the world's best React application, but it's an application that tries to do a number of different things with React and Redux, create some web components and do some other things. So it's just a reference app if you want to look at it. We did this as part of so we have clients who come to us and say, hey, should I use, and so for the past 20 years, it's should I use X, Y, or Z, right? And X, Y, and Z change over time, but the answer always is, I don't know. What are you trying to do? What are you trying to achieve? So there are companies where React would not be a great idea for them because they can't agree on anything, and React's too free-form for them. Or there are companies where they really want something that's very specific to a particular framework, and React and other frameworks are very general purpose. But this comparison came about from a customer saying, I want to consider Vue, Dojo, Angular, and React. And we know we want to use TypeScript. So the concern at the time, this was about a year ago, was, hey, is TypeScript and React, are they going to work well together? Because most of the examples don't use, or at the time didn't use TypeScript. And so we basically did the legwork and showing where the differences and similarities were. And because JavaScript and TypeScript are so flexible, the four examples start to look quite similar because we're able to sort of turn Angular into something a bit more like React, and we're able to just make things work the way we would want them to work. But it also highlights the differences and distinctions between the approach we took. And then we just updated the React one in time for this talk, so it's current. So it's not a year old. It's I wouldn't say it's the world's best application, but again, it's just another example to look at. Now, I mentioned that I work on Dojo, so I'm not here to really sell you on Dojo. I'm just here to tell you what Dojo is. So how many of you used Dojo 1 like back in the day before React? So a handful of people. Okay, so it shares the name, but the history is really interesting. So in 2008, Facebook hired SitePen, our company, to teach them how to write JavaScript. And so we went to this hotel in Palo Alto and trained Facebook's for 126 of their first 127 engineers on how to write JavaScript. The one who skipped was Mark Zuckerberg because he didn't need training at that point. And so we basically spent 2 days with our team teaching them how to write JavaScript code. And we taught them in a way that was very opinionated and very different and very Dojo-y. But we didn't tell them to use Dojo because it was Facebook and they needed to do their own thing. And so what was interesting, though, is they used Dojo for a while, and there were things they liked about Dojo. They liked sort of the component model. Like the whole component model thing comes from Dojo, but Dojo didn't invent that. That comes from like Laszlo or Flex, right? Which then comes from Delphi. Everything goes back to Delphi eventually, or Interface Builder, right? So like the whole web components thing and the React components thing, it's been done like 50 times before in different programming languages, but it's been reinvented at least 4 or 5 times in JavaScript as well to get to where we are today. Anyway, the point is, so there were 2 sort of seminal projects early in the day that did the equivalent of virtual DOM diffing without really doing it the way we do it today. There was Dojo, which had a vector graphics implementation that would support SVG, Canvas, Silverlight, or VML. And then there was this tool called Bespin, which was a Canvas-based code editor that virtualized real-time rich text editing, but rendered it to Canvas, which that later became Cloud9, which is now Amazon's Cloud9 code editor. Anyway, both of those projects virtualized the DOM, but for just like a component on a page, or just a specific set. And the reason you didn't really think, hey, I'm going to do this for my whole application or my whole page, was because IE 6 through 8 sucked, right? So the memory allocation you had for those old browsers was so small that if you tried to do what you do today with React in a whole page, you would instantly be thrown into garbage collection mode and you would have no resources available for your application. But as soon as you could liberate IE 6 through 8 from your stack, this idea of making the entire page virtualized in memory is actually really powerful and really cool. So by 2013, that was roughly the time when people stopped asking about IE8 support. So it was a really good time to make that transition. So long story short, Dojo did some of the stuff React does early on. And then about 5 years ago, we decided it was time to start thinking about Dojo 2. And so we started a rewrite, and we rewrote about 6 or 7 times. And we kept asking ourselves, what should Dojo be? Because if we're going to create this thing, we want something that we really want to use. So sort of the foundational pieces where we want a TypeScript framework that's relevant for the enterprise. We really like what React does because React really liked what Dojo did. We like the virtual DOM approach. We like, this sort of component model. We like reactive state. But there are some things we don't like about React. One of which is sort of when I need to do things with a DOM element that are not like, I need to change the dimensions of something, or I want to use an intersection observer on a DOM component, or I want to do a web animation. The typical default React answer is fine, use this sort of crufty way to get access to the DOM element and just go to town. The Dojo way is to say, okay, we've gone through all those use cases and we provide those as properties you can react to. So if you need a web animation, we're going to give you the properties back that you would get from a web animation and you can react to those. If you need to resize a node, we're going to give you properties for the dimensions rather than the DOM node. If you need an intersection observer, we're going to tell you a property on whether something is inside something else or not. So we've looked at things the other probably big difference between React is we've tried to put together a more comprehensive framework, not a kitchen sink framework like Angular, but more of a, this is the router, this is the component model, this is the virtual DOM system, this is the build system. The build system by default, so there's a comparison on the real world reference application. So real world is a collection of reference applications people have written for a bunch of different frameworks. And someone wrote a comparison of all of them this year, and Dojo was faster and smaller than React, than Angular, than pretty much everything else. But it's because we cheat. And I say that we cheat in a nice way in that we look at your default routes and your default components, and we optimized for your first initial paint by creating a really small bundle size. So we do code splitting based on your application itself, rather than you having to go through the process of doing all that work manually. So the idea really is we've said, all right, if we were to rewrite React, or we were to rewrite Dojo, rewrite React, rewrite other frameworks, what would we end up with? And we would end up with something like Dojo. So I'm not saying any of you should ever use Dojo, but it's worth a look if you're interested in sort of how we do it. I mean, it uses JSX syntax, it uses TypeScript, it renders the default function. So for a React developer, it's very quick to jump in and sort of understand what we're doing. But again, I think the biggest thing to take away from sort of React and TypeScript is those two technologies have kind of taken over, but they don't have to dominate. They can influence everything else as well. So that's a good thing. So wow, that is 29 minutes and 24 seconds. That's pretty spot on. So cool. Thank you.